Yeah. Hello and welcome to my YouTube channel. Today I'm going to be talking about Kirchhoff's current law. And Kirchhoff's current law simply says that the algebraic sum of current at a node is zero. So if you have a circuit diagram and you can identify a node on that circuit diagram, the algebraic sum of current at that node is zero. Now what do you mean by algebraic sum? So algebraic sum here, we are going to be looking at what? The current that are entering the node and the current that are leaving. So what we tend to do is that the current that are leaving, that are entering, we can indicate them as positive. Those that are leaving as what? Negative. Right? And then we have here an example here. If we look here, we have a node here. Why? Because it's the point where three or more components are connected. Right? So this is a node. So how do we do the algebraic sum? So I1 here, you can see is entering the node, so consider that as positive. And then I2 is leaving, so it's going to consider as negative, and I3 is leaving, we have one negative. So we have I1 minus I2 minus I3 equals to 0. And this is just going to be equals to I1 equals to I2 plus I3. So based on this, the answer that we got here is the reason why we have another way of stating the Kirchhoff's current law, which is that the sum of current entering should be equal to the sum of current leaving. Because you can see here, minus is for the current that are leaving, and then when you set them up, you count what? Positive. So we can say the sum of current entering is equal to the sum of current leaving. And that's the law that is easier to use, because we just have to identify our nodes in the circuit, and then we look at the current which are entering and the currents which are leaving. The sum of current entering will be equal to the sum of current leaving. And we are going to using this principle to the next example here that we have. We can see this one too. We have what? A node here, right? Why? Because we have what? It's a point here in junction where three or more nodes are connected. Here we have three that are connected to it. So we have node A. Now, here we can see that at node A, I1 is entering and only I, and then I3 and I2 are leaving. So that will just be what? I1 equals to I2 plus 3. Then we come here, we have a node, which is node B. So again, you can pause this video and try to see what answer you are going to get for this. And the way you do it was realize that at node B, I3 and I4 are entering the node, and then I5 and I6 are leaving the node. Then that gives us what? I3 plus I4 equals to I5 plus I6. So this is how you apply Kirchhoff's current law. See you in the next video. Bye-bye.